Hello everyone. Today we are going to understand the data science project on the topic face recognition, image compression plus feature reduction, principal component analysis PCA. Okay, so let's understand first what is PCA. PCA stands for principal component analysis. It is a dimensionality reduction technique used in machine learning and data science. It helps reduce the number of features in a data set while preserving as much important information variance as possible. Instead of working with thousands of features like pixels in an image, PCA transforms the data into a smaller set of new variables called principal components. These components are uncorrelated and ranked based on how much information they retain. In simple terms, PCA helps in reducing data size compression, removing noise, improving model performance, making visualization easier. Okay, so let's start. First is importing libraries. Import numpy as np, import matplotlib, import matplotlib.pyplot.splt from sklearn.datasets, import fetch olivetti faces from sklearn.decomposition, import PCA. Okay, so here we import the necessary libraries required for the project. NumPy is used for numerical operations and handling arrays. Matplotlib is used for visualization, allowing us to display images from scikit-learn. We import fetch Olivetti faces to load a real world face dataset and PCA to perform dimensionality reduction. Okay, now here loading the dataset. So faces equal to fetch Olivetti faces, x equal to faces dot data, image equal to faces dot images. So in this step, we load the Olivetti faces dataset, which contains grayscale images of different people. The data set is structured in two formats. First, faces dot data and faces dot data flattened images. Each image converted into a 1D array of pixel values, and faces dot images original 2D images 64 by 64 pixels. Okay, so we store this in variable x and images respectively. The flattened data is used for applying PCA, while the original images are used for visualization. Okay, after that we need to applying the PCA. Okay, feature reduction. So PCA equal to PCA and components equal to 50, x PCA equal to PCA dot fit transform x. Okay, so here we apply PCA to reduce the number of features. Each image originally has 14096 features, 64 by 64 pixels. Using PCA, we reduce it to 50 principal components. N components equal to 50 means we keep only the top 50 most important features. Fit transform learns the pattern in the data and transform it into a lower dimensional space. Okay, so this step significantly reduces the data size while retaining most of the important information. After that, we come to the reconstructing images. So under reconstruct images, x reconstructed equal to PCA dot inverse transform x PCA. So after reduction the data, we reconstruct the images using inverse transform. This step converts the compressed data back to its original shape 4096 features. However, since we used fewer components, the reconstructed images may lose some details. This demonstrates how compression affects image quality. After that, we come to the visualization part. Okay, so here with fig x x equal to plt dot supply, subplots 25 fixed size equal to 10 4 for I in range 5. Okay, so here we in this section we visualizes the results. We create a grid of 2 rows and 5 columns. Okay, so the top row shows original images, the bottom row shows reconstruct compressed images. Okay, so we use a loop to display the first 5 images. The reconstruct images are reset back to 64 by 64 format before displaying. So this comparison clearly shows how much detail is preserved after compression. Okay, now here you can see the image. So if here it displays a visual comparison between an original high resolution between an origin 1 minute between an original which is high resolution facial image and its compressed counterpart. The compressed phase exhibits a noticeable loss of fine detail and increased blurriness, which typically illustrates the effects of loosey dimensionality reduction or data compression algorithms. Okay, so additionally, the series of empty grid plots alongside the images indicate a layout designed to showcase further analytical steps or principal components that remains unrendered. Okay, so if we talk about here the business problems and solution, so in real world scenarios companies often deal with large amount of image data such as in face recognition systems, security surveillance or social media platforms. Storing and processing high resolution images requires significant storage space and computational power. So the business problem is high storage cost, slow processing time, inefficient data handling. The solution using PCA reduces the size of image data by keeping only the most important features. This allows businesses to store compressed images and process them faster without losing critical information. For example, in a face recognition system, instead of comparing full images, the system can compare compressed representations, making it faster and more efficient. So in summary, PCA helps business optimize storage, improve performance, and reduce cost while still maintaining acceptable data quality. Thank you.